for end semester. Okay, before moving on, I will be covering first unit. Tejaswini will be covering third and fifth unit, and Harsha Anna will be covering second and fourth unit. So, okay, what is meant by probability? So, before moving on to the concepts of probability, we need to know some terminologies. So, what is an experiment? Any activity where outcome is subjective to certainty. For example, if you are doing something, for example, if you are tossing a coin or rolling a fair die, you will be getting some output which may or may not be unique. So that's called as experiment. Sample space is nothing but set of all possible outcomes. That is, if you are tossing a coin, the outcomes would be getting a head and getting a tail, right? And if you are rolling a die, for example, you will be getting 1, 2, 3, 4, 5, and 6. So sample space is denoted by capital S, and you will be writing all the possible outcomes inside this curly bracket. Next, what is an event? Any subset of the sample space. It is simple if it consists of only one outcome, and compound if it is more than one. For example, in tossing a coin, we have probabilities of getting either a head or a tail. So we don't know what will happen now, right? So an event is nothing but it is a subset of a sample space. It may be anything. It is simple if it consists only one outcome, and it will become compound if it is more than one. So okay. So what are the properties of probability? First probability is probability of any event should be greater than or equal to 0. So the probability greater than or equal to 0, and it should lie between 0 to 1. It can be 0 and it can be 1, but it should not violate this property that the probability should always lie between 0 and 1. It will not go beyond 0, or after 1 it won't move. The probability will always stick on to this bound 0 to 1. And probability of a sure event is 1, and probability of an impossible event is 0. Okay. So here we can see a Venn diagram representing the relationship between two sets, that is A and B. So if you clearly look, this will be the universal set, and this is the event A, and this is the event B. So what is the probability of event A occurring? So it will be some probability of A equals to some X, probability of B equals to some Y. So, and also there is an important terminology, that is A intersection B, probability of A intersection B and probability of A union B. So probability of A intersection B is nothing but probability of both A and B occurring simultaneously. So which is this part? This shaded part is nothing but a probability of A intersection B. And the probability of A union B is nothing but the probability of either A or B happening. So which is denoted by probability of A union B. So also there might be a chance that a question also asks us to find what is the probability of P of A minus B or P of B minus A kind of thing. So the formula for finding P of A minus B is nothing but P of A minus P of A intersection B. So this is A, right? So if we clearly view, this part is also A, but this part is also covered by B. So we need to remove that and find what is the actual probability. That is probability of A minus B. So taking the whole area and we are subtracting this A intersection B. So we get probability of A minus B. Likewise, probability of B minus A is nothing but probability of B minus probability of A intersection B. So we are just taking the probability, that is the set B, and we are subtracting it to probability of A intersection B. So we arrive at probability of B minus A. So remember these two formulas. Also, the summation of probability always leads to 1. So that is the probability of all the events, sum of probability of all the events will always be equal to 1. D1. Okay. So remember the two properties, that is probability always lies between 0 and 1. If it is 0, it is impossible event. If it is 1, it is sure event. And also the sum of probabilities always always be 1. So that is P of A plus P of A dash equals to 1. P of A bar is nothing but the complement of probability. So this is the chance of A event occurring. So this is the what are the chances of A not occurring. So always some event plus its complement would be 1 in case of probability. Also, there are certain cases where we may arrive at this situation that probability of A intersection B equals to 5. Null set. So this is called as like a disjoint. 1 minute. Sorry for the interruption. So what we saw is there might be some situation occurring like probability of A intersection B will also become null set or disjoint. So that kind of situation is called as mutually exclusive. So mutually exclusive events is nothing but the two events whose intersection would be some null set. There won't be nothing there won't be any intersection between the event A and B. So these type of events are called as mutually exclusive events, and they cannot occur simultaneously. For example, in an event of tossing a coin, either head or tail can come. So we cannot get a head and tail in tossing off a single coin. And winning and losing a game is not possible, right? So these type of events are mutually exclusive events. And not mutually. For example, what is the example you would give for not mutually exclusive events is that scoring 450 and losing in a game is possible, right? So scoring 450 in a game and losing that game is possible. And driving and listening to music. So that is also an example of not mutually exclusive events. Mutually exhaustive events. So there is also something called as mutually exhaustive events. So if you consider some events, that is A, B, C, if you take union between all these events, you would arrive at the sample space, right? So I already told sample space is nothing but the set of all possible outcomes. And also we saw that event is a subset of a sample space. So if you take union between all the events, you will arrive at the sample space. So remember this kind of things. So for example of mutually exhaustive event is that event A1, let's take getting a even number from rolling a fair die. So getting a even number, so sample space would be 2, 4, 6. Event A2 is getting a odd number when rolling a fair die. It would that would be 1, 3, 5. So if you take if you take union between these two sets, you will arrive at the total sample space. That is the fa- uh, outcomes of the outcomes of the outcomes of rolling a single fair die. So next is something we will be looking, that is independent event. So the name itself suggests that occurrence of one event is not influencing the appearance or occurrence of another event B. Uh, for example, uh, rolling a fair die and tossing a fair coin is independent, right? So one event is not influencing the other event to happen. So that is called as independent events. If we delve into the classical definition of probability, probability suggests that probability equals to, the notation is P of A, number of favorable cases divided by total outcomes or sample space, we can say total cases. So if we take P of A equals to some n by m, so m is the total cases and n is number of favorable cases happening out of those total cases. So we already know that P of A plus P of A complement is 1. So what will be P of A bar? 1 minus n by m. We also have something called as axiomatic definition of probability. Axiomatic is nothing but we already saw those things. Probability should not be negative, and always the probability will lie between 0 and 1, and the sum of probabilities will also always be 1. And if A and B are mutually exclusive events, their intersection would be some null set. Okay. So addition theorem. So what is mean by addition theorem? So P of A union B equals to P of A plus P of B minus P of A intersection B. I will tell you the concept, logic behind this. Okay. let us take, there are some two events that is happening, A and B. So A union B is nothing but this shaded part. So how will you find A union B when A and B and intersection between A and B are given? So A union B is nothing but probability of A, probability of B you are adding, and you are subtracting it, you are subtracting P of A intersection B. So we will be getting probability of A union B. Okay, difference of sets we already saw. P of A minus B is nothing but P of A minus P of A intersection B. And bounds of the probability is between 0 and 1. Okay. So now what if events A and B are independent? So if A and B are independent, so occurrence of one event is not influencing the occurrence of another event, we say that probability of A intersection B will be probability of A into probability of B. So this is the general formula when the question says that the two events are independently occurring, and also probability of A union B would become probability of A plus probability of B minus probability of A into probability of B. So likewise we also have that what if complement of A bar and complement of B bar are independent. So same formula applies here. A bar intersection B bar is equal to probability of A bar into probability of B bar. Likewise for A and B bar. Likewise for B and A bar. Okay. Probability of A bar into probability of B. So these are the four types of formulas for in case of independent events. So okay. So now we will be seeing some like statement forms we will be seeing, which we will be converting into notation form. For example, the probability of either A, the question says either A or B, the probability would be probability of A union B. Either right, either A or B can occur. So it is probability of A or B, that is union B. So what if it is both A and B? And so both are happening. So that is nothing but A intersection B. Neither A nor B. Probability of A bar and probability of B bar. So we say that A and A also is not happening, B also is not happening. So that is why we get probability of A bar intersection B bar. Okay. So what if there, let us consider some three events. A comma B comma C. So what is the probability of just A occurring, just B occurring, just C occurring is that for A occurring it is probability of A intersection B bar intersection C bar. For just B occurring, it is A bar intersection B intersection C bar. For C occurring, it is A bar intersection B bar intersection C. Okay. And what is the probability of, let us consider now two events. Consider event A and B. A not B or B not A. So that is nothing but probability of A intersection B bar union probability of A bar intersection B. Okay. So this is the formula for A not B or B not A. Okay. Also, there's something called as De Morgan's theorem. In case of two events, what will be the probability of A union B complement? That is nothing but probability of A bar intersection probability of B bar. So what will be the formula for probability of A intersection B complement, which is probability of A bar union probability of B bar. So this is same as that of that negation law which we studied in discrete mathematics. Okay. Till now, does anyone of you have any doubts? Hello? Okay. So now we can move to problem solving. Question one. One card is drawn from a pack of 52 cards. So what is the probability that it is either a king or a queen? So first, when you see a question, first you will be so first you need to write what is the sample space, what are the possible set of outcomes, and from that you can get all the things you want. So first, what will be the sample space? 2, 3, 4, A, J, U, K, yes, sorry. So n of s would be 52, which is already given in the question. So pack of 52 cards, we are selecting a card. So they are asking us to find what is the probability of either a king or a queen occurring. So let us assume. So wait, first we will write it in type in terms of notation. So I already told that either A or B is nothing but probability of A union B. So let us assume A as the event of king, B as the event of queen occurring. So there are totally four kings, right? Two from red and two from black. Four kings. Probability of A, the formula for probability of A is number of favorable cases divided by total number of cases. So number of favorable cases is n of A, total number of cases is n of S. 4 by 52. Okay. So also n of B is also 4. So we have 4 queen, and probability of B will be 4 by 52. So P of A union B equals to, so we are now using addition theorem. P of A plus P of B minus P of A intersection C, A intersection B. So if you clearly observe, A intersection B is 0, right? Because happening of a king or happening of a queen is not, like, it is not influencing one. So king is not influencing the event of queen and vice versa. So P of A intersection B is 5. Both are independent events. So P of A union B equals to P of A plus P of B. 4 by 52 plus 4 by 52 is nothing but 8 by 52, 2 by 13. You can leave it in the form of fraction, or otherwise, if you want to write it in the form of decimal, you can write it like 4 decimal places. Up to 4 significant decimal places you can write. Okay, next problem. A bag contains 5 white and 10 red balls. 3 balls are taken out. 3 balls are taken out at random. So find out the probability that all the 3 balls that are drawn are red balls. So first we will write the sample space. So that is x comma y comma z, where x belongs to white or red, y belongs to white and red, z belongs to white and red. So we will be drawing 3 balls, and we are asked, we need to find what is the probability of all the 3 balls that we are drawing is red. So first of all, we need to like write what is the sample spaces. 3 balls we are naming it as x, y and z. X can be either W, white or red, Y can be either white or red. So the sample space would be W, W R, W R W, R R W. Likewise, it will be going. Okay. So here we can proceed this question in 2 ways. So if the default case is without replacement. So the default case is without replacement. Without replacement in the sense, if you are drawing a ball, so you are not putting it back again in the bag from which you draw the previous ball. So you are just taking a ball and you are making a note of that ball and keeping it aside. So this is called as without replacement. So without replacement, the probability of all the 3 balls drawn are red is that. So totally there are 10 red balls, right? And total balls is 15 balls. First you are drawing one ball and one ball. So here count decreases because it is without replacement. You are keeping that ball aside. And again 8 by 13 because you are drawing 3 balls. So this is one default case. Another method is to use the combinations. So n of s is the total number of ways is for drawing 3 balls is 15C3, that is NCR. Formula for NCR is n factorial by n minus r factorial into r factorial. So if you solve, you will get 455. And 3 balls drawn are red. So let A be the event where 3 balls drawn are red. So A is the event of getting 3 balls red. So now N of A would become 10C3. Why? Because there are totally 10 balls and you are just taking 3 red balls from those 10. So it actually becomes 10C3, which is nothing but 120. So if you substitute in the formula, P of A is equal to N of A by N of S, 120 by 455. So if you want to write in 4 places of decimals, it is 0.2637. Okay. From a pack of 52 cards, 2 cards are drawn. They first being replaced. The first card which you are drawing is being replaced before second card is drawn. So here the default case won't apply because in the question itself they have mentioned that it is with replacement. Find the probability that the first one is diamond and the next one is a king. First one is a diamond. Second one is a king. So N of S is totally 52 cards. So if we write it in the form of notation, that is probability of drawing first card is diamond and the next card is a king. It is probability of A intersection B, probability of A into probability of B, because as this event is independent event. So the number of diamond card is 13 out of 52 into the number of king card will be 4 by 52 only. You are not reducing the count because the question says that it is with replacement. So the final answer is 1 by 52. Okay. The next question. A bag contains 30 balls, number from 1 to 30. One ball is drawn at random. So one ball is drawn at random. Find the probability that the number on the ball drawn will be multiple of 5 or 7. So probability that number on the ball drawn will be multiple of first subdivision is 5 or 7. Second subdivision is 3 or 7. So the total, that is sample space, the number of outcomes is 30. Let A be the event of getting a multiple of 5. B be the event of getting a multiple of 7. And C be the event getting a multiple of 3. Okay. So first, what will be the N of A? What will be N of A, N of B, N of C from the sample space? So multiples of 5 between the numbers 0, 1 to 30 is 5, 10, 15, 20, 25 and 30. Multiples of 7. 7, 14, 21 and 28. Multiples of 3. 3, 6, 9, 12, 15, 18, 21, 24, 27 and 30. So, probability of A is n of A by n of S. So, what is n of A? 6 by 30. 1 by 5. Probability of B is n of B by n of S. N of B is 4 by 30, which is 2 by 15. Probability of C, getting a multiple of 3 is n of C by n of S. N of C is 10 and the total count is 30, so 1 by 3 upon simplifying. So first subdivision, the question says that what is the probability that the number on the ball drawn will be multiple of 5 or 7, or in the sense it is A union B. Okay. Probability of A plus probability of B minus probability of A intersection B. So in this case also the probability of A intersection B is 5 only, because if you observe uh, the A event is getting a multiple of 5 and the B event is getting a multiple of 7. So there is no common term, that is intersection between these two events, that is A and B. So it is 5. So we just normally add 1 by 5 plus 2 by 15. So which is 1 by 3. Second subdivision is probability of getting a multiple of 3 or 7. So we are in the sense union. So probability of C plus probability of B minus probability of C intersection B. So here intersection occurs. Why? Because 3 and 7. So it should be multiple of 3 and 7. So if you look, 21 is common multiple of 3 and 7. So we write P of C intersection B as 1 by 30, as there is one element out of 30 elements. P of C is 1 by 3 plus 2 by 15 minus 1 by 30. Upon simplifying, you will get 13 by 30. Okay. So the next question. So this is a very famous question, which we also had this question in CAA 1. A can hit the target in 4 out of 5 times. Okay. A can hit the target in 4 out of 5 times. So the probability of A will be 4 by 5. B can hit the target in 3 out of 4 times. So the probability of B hitting the target would be 3 by 4. So find the probability that subdivision target being hit once they both try. Target being hit once they both try. And the second subdivision is target being hit exactly by one person. Okay. So target being hit once they both try, in the sense A should try and B should try simultaneously. They both should hit the target. So in notation form, it is probability of A intersection B. So if we clearly observe, these two events are independent events. So A is hitting the target in 4 out of 5 times and B is hitting the target in 3 out of 4 times. So one event is not influencing the other event. So they are just telling the question that they both should hit the target if they try. So which is probability of A into probability of B. Probability of A is 3 by 4 into 4 by 5. 3 by 5. One minute. So actually we need to find the probability of A union B. So why? Because the target is being hit once they both try. So either A can hit the target or B can hit the target. So sorry for the inconvenience. So it is either A can hit or B can hit. So which is probability of A union B. So we already found what is probability of A intersection B. So now addition theorem. We need to substitute the values in the addition theorem. 4 by 5 plus 3 by 4 minus 3 by 5, which is 19 by 20. So the second subdivision is target is being hit by exactly one person. So either A hits, if A is sitting, B is not hitting, and when B is hitting, A is not hitting the target. So let us assume this as P of A. P of A into P of B bar plus P of B into P of A bar. So that is probability of A is 4 by 5. So what is probability of B bar? It is 1 minus probability of B. What is probability of A bar? It is 1 minus P of A. So probability of B bar is 1 minus 3 by 4, 1 by 4. This is 1 minus 4 by 5, 1 by 5. So 4 by 5 into 1 by 4 plus 3 by 4 into 1 by 5. The final answer is 7 by 20. Did you guys understood up to this point?
Yep.
So moving on to the next question. So if probability of A equals 0.65, probability of B equals 0.40, and probability of A intersection B is given as 0.24, then check whether A and B are independent or not. So the values of A, probability of B, and intersection between them probability is given. So we are asked to find whether the two events are independent or not. So as we all know, the relationship between the two events when they are independent is probability of A intersection B equals probability of A into probability of B. So if you multiply 0.65 into 0.4, you would get something 0.26. So which is not equal to probability of A intersection B, because probability of A intersection B is 0.24. Hence A and B are not independent. Okay. Moving on to the next concept which is conditional probability. Definition. If A and B, let us consider two events, which is A and B. So if A and B are any events in sample space and P of B is not equal to 0, then the conditional probability of A given B, the probability of A given B is nothing but, so the notation of A given B is A bar B, or A given B equals probability of A intersection B by probability of P of B. So that is why the probability of B is not equal to 0. So what if the probability of B becomes 0? The entire term, probability of A given B, would become some infinite value, would get some infinite value, which is not possible in case of probability. So probability of B should not be equal to 0. So in case of probability of B given A, nothing but probability of A intersection B. Probability of A intersection B and probability of B intersection A are same, divided by probability of A. Here probability of A is not equal to 0. So where P of A and P of B represent the marginal probabilities. And P of A given B and P of B given A represent the conditional probabilities. So general multiplication rule of probability. So multiplication rule of probability, we derived it using this formula only. So we know that probability of A given B is probability of A intersection B divided by probability of B. So from this formula, we can find what probability of A intersection B is. Probability of A given B into probability of B. And probability of A intersection B is equal to probability of B given A into probability of A. So there is a note point. If A and B, let us consider, are two events in a sample space, we can say that A is independent of B. A is independent of B if and only if probability of A given B equals probability of A. So what if the two events are independent? The probability of A given B becomes that is probability of A intersection B by probability of B, right? So if this is if the two events are independent, it is probability of A into probability of B divided by probability of B. So we can cancel and we arrive at the solution that probability of A given B when both are independent is probability of A. Similarly, for probability of B given A, it is probability of B. Only when both the events A and B are independent. So this is all about the concept of conditional probability. Now we will be solving some problems related to conditional probability. First question. So from a pack of, again, we have that pack of card question. N of S will be 52. One card is drawn at random. Given that the card is a face card. So there are totally 12 face cards in a deck of 52 cards. What is the probability that it is a queen? Okay. So let A be the, so first you define what are all the events. So let A be the event that the card is a face card, and you write what is n of a, what is n of s, what is p of a, and the next event, let b be the event that the card is a queen. N of s will be 52. N of b is 4, right? So there are four queen cards. P of b is n of b by n of s, 4 by 52, 1 by 13. So they have asked what is the probability of a queen card given face card. So what is the probability of getting a queen card given that a face card occurs? So this is event A, sorry, this is event B, this is event A. Probability of B given A is probability of A intersection B by probability of A. So we already found what is probability of A. So we don't know what is probability of A intersection B. So probability of A intersection B is 4 by 52, right? Because the face card contains the 4 queen cards in it. So it is 4 by 52. Probability of A intersection B is 4 by 52 because the face card contains the queen card in it. 1 by 13. Probability of B given A is 1 by 13 by probability of A is 3 by 13. 1 by 3. Next question. In a class, 40% study mathematics. So, in a class, there are students, 40% of students who study mathematics, 30% of students who study physics, 50% of students who study both mathematics and physics. So, probability of mathematics is 40 by 100. Probability of physics is 30 by 100. Probability of M intersection P, that is both mathematics and physics, is 15 by 100. So what is the probability that the student studies mathematics given that the student studies physics? So which is nothing but P of M intersection P by P of P. The values are already given directly. We need to just substitute. Intersection is 15 by 100. Probability of student studying physics is 30 by 100. So the final answer is 1 by 2. So till this, any doubt? Okay. So the next important concept is total probability. Let's take some events which are mutually exclusive. Mutually exclusive in the sense the intersection of these events will give us a null set, and the union of those sets will give sample space in case of mutually exhaustive. So we are taking events which are mutually exclusive and mutually exhaustive. In a sample space, yes, mutually exclusive and mutually exhaustive. Then probability of A would become probability of bi into probability of a given bi. Summation I is equal to 1 to n. Okay, so here if you are having some probability, okay, probability of b. So this is b1, this is b2, and this is bn. So this is probability of b1, this is probability of b2, this is probability of bn. Okay, so there is something common between these events, which is a. So there is some fixed event between these b events, that is a, probability of a. So a will be given. So if a is given, see probability of, here it is a given b1, here it is a given b2. So let us assume that it is a given b1, b2 and b3. So the total probability is nothing but the product of p of bi into p of a given bi, and we are adding it. So we are multiplying this, we are multiplying this, we are multiplying this and adding to get some probability, which is the total probability. We are just adding all the probabilities with some conditions in it to achieve at some total probability. So it will be clear when we solve some questions based on total probability. Okay, wait. I will...
கௌதம் கொஞ்சம் மேல ஒரு தடவை ஸ்க்ரோல் பண்ணி காமிக்கிறியா?
ஓகேடா, ஒரு நிமிஷம்.
இது மட்டும் வந்து
இந்த ஒரு நிமிஷம், ஒரு நிமிஷம்.
ஓகே ஓகே.
I'll go take mathematics book and come. Am I audible?
Yep.
Okay.
அந்த ஃபார்முலா 1 மினிட் காமிக்கிறியா மேல இருக்கிறது? ஓ ஓகே ஓகே ஓகே, இதான். ஓகே ஓகே, காட் இட். நான் தப்பா
ஓகேடா.
படிச்சிட்டேன்.
ஓகே. சரி, ஓகே. Example 1 in total probability. A person has undertaken a construction job. The probabilities are 0.65 that there will be strike, 0.80 that the construction job will be completed on time if there is no strike, and 0.32 that the construction job will be completed on time if there is a strike. So wait, let me write. So the given is the given part is probability is 0.65 that there will be strike. Okay, let A be the event that the construction job will be completed on time. and B be the event that there will be some strike. There will be strike. So here probability of strike is given as 0.65. Probability of strike is given as 0.65. So what will be the probability of no strike? 1 minus 0.65, which is 0.35. Okay. And 0.80 be the probability that the construction job will be completed on time if there is no strike. Okay. So P of A given B bar is 0.80. So the probability that the construction job will be completed on time given that there is no strike. If there is no strike means given that there is no strike, which is probability of A given B bar, and probability of 0.32 that a construction job will be completed on time if there is a strike. So completed on time is A, given strike is B, 0.32. Okay, so determine the probability that the construction job will be completed on time. So there is some event probability of A, right here. We are asked to find what is the probability of A. Probability of B is given and A given B bar and A given B is given. So probability of A is probability the construction job will be completed in time. Okay. So the formula is probability of A. So this is the probability which you want to find equals probability of B into probability of A given B plus probability of B bar into probability of A given B bar. So what the total probability formula says that first you are just multiplying probability of B with the conditional probability of construction job that will be uh, happening if there is a strike, and you are multiplying the construction job won't happen when there is when that is given that there is no strike. So you are just multiplying the terms and adding, so which is 0.65 into 0.32 plus 0.35 into 0.8. So the final answer is 0.488. Okay. So did you guys understand?
Yep.
Okay. So the next concept is Bayes theorem. So the final concept of this lesson is Bayes theorem. So similarly, we are considering some events B1, B2 till Bn to be some mutually exclusive and mutually exhaustive events in a sample spaces such that the probabilities of all the events is greater than 0 and it lies between 0 and 1. So probability of B given A is probability of B R into probability of A given B R divided by the total probability, that is P of A. So what is P of A? Probability of B I summation into probability of A given B I, right? So this is the formula for calculating the probability of B when A is given. So the Bayes theorem is nothing but the Bayes theorem. The formula for the Bayes theorem is nothing but the ratio of probability of A to the total probability A given B to total probability. So it is the ratio of probability of B when B of A when B is given to the total probability, that is P of A. Note that P of B1 plus P till P of Bn equals to 1, and also P of B1 given A plus P of B2 A equals to 1. Okay. So we'll solve some questions related to this Bayes theorem. In a test, a candidate either guesses or copies or knows the answer to MCQ with four choices. So, four choices. Totally, there are four choices. The probability that he makes a guess is 1 by 3. So, let us consider event A that he makes a guess. So, probability of A is 1 by 3. So let us consider event B that he copies the answer, which is also given in the question 1 by 6. So the probability that the answer is correct given that he copied. So let us assume that event where the answer is correct as E given that he copied. He copied is B. E given B is 1 by 8. Okay. So we need to find the probability that he knows the answer given that he correctly answered. So first we will write the formula. P of A given E is equal to P of A into probability of E given A by the total probability. So okay, here there are totally of 3 events, right? We are also having a C event, that is he knows the answer. A event is guessing, B is copying, C be the event that he knows the answer. Now we will write the probability of each and every event. Probability of A is 1 by 3. Probability of B is copying the answer is 1 by 6. Probability of knowing the answer is, see, knowing the answer is not given in the question. So we need to find what is the probability of C, event C. So which is, so we already know that the sum of the probability is 1. So we are just subtracting 1. 1 minus 1 by 3 plus 1 by 6. So we will get the probability as 1 by 2. Probability of C is 1 by 2. Okay. So now probability that answer is correct, he copied, is 1 by 8. Probability that answer is correct given that he copied is 1 by 8. Also, answer is correct given that he knows the answer would be 1, right, because it is a sure event. Given that he knows the answer, his answer would be correct. He's not copying or like he's not guessing the answer. He knows the answer and he is just writing what is the correct answer. So that answer is correct. So The answer is correct given that he knows is 1. It is a sure event. Also, probability of answer is correct given that he guesses the answer is 1 by 4. He's just guessing one answer out of 4 choices. So in the question it is given, right? Answer with 4 MCQ, 4 choices. So he's just guessing. So the probability would be 1 by 4. So now you need to substitute all the values in the formula. So what they have asked us to find the probability that he knows the answer given that he correctly, okay, probability of C given E, which is probability of C into probability of E given C divided by probability of E. Probability of E is nothing but probability of A into probability of E given A plus probability of B into probability of E given B plus probability of C into probability of E given C. So the final answer would be the overall, that is the total probability that he knows the answer to the question that he correctly answered is 24 by 29. Okay. Moving on. Okay. So the next question in Bayes theorem, a factory has two machines, 1 and 2. Machine 1 and 2 produce 30% of and 70% of items respectively. So the probability that machine 1 produces is 70%, sorry, 30%, and machine 2 is 70%. Further, 3% of the item produced by machine 1 are defective and 4% of the items produced by the machine 2 are defective. An item is drawn at random. If the drawn item is defective, find the probability that it was produced by machine 2. So we will write it type terms of notation. So we need to find the probability that it was produced by machine 2 by M2 given the item is defective. So here we can clearly see that the item is defective is the common element between both the events. Item is defective. It was produced by M2. Okay. Okay, fine. Let P of D be the event that item is defective. The probability that it was produced by machine 2, we need to find probability of the machine is defective given that it is produced by machine A is already given in the question as 3%. And probability that the machine is defective but it is produced by B is given as 4 by 100. So if we substitute in this formula, first we will find P of D. P of D is P of A into P of D given A plus P of B into P of D given B. So P of D is 0.3 into 0.03 plus 0.7 into 0.04. So now we will substitute into the base formula. We need to find it was produced by machine 2 given that the item is defective. So which is probability of B into probability of D given B divided by probability of D, which is 0.7 into 0.04 by 0.037. If you simplify, the answer is 0.756. Since the question is given in terms of percentage, we will convert into percentage 75.6 percentage. Okay, up to this, is it clear to you all? Okay, that's all from my side. This is what the chapter 1 deals with: conditional probability, independent events, Bayes theorem, and the total probability, and some basic questions based on probability. Thank you.
Hello? Okay, so we'll take a short break and start by 6 and it starts.
Tejaswini, will you continue?
Yeah, we'll take a short break and start by 7.
Hello.
Hello.
Yeah, sorry, I was just checking. Okay, so we'll be starting now. Everyone can hear me, right? Okay. Okay. So discrete random variables. So what is a random variable? Random variable is basically uh, a variable which represents the outcome of an experiment. Let's say we take an example of tossing two coins. So random variable heads represents the number of heads here. So here we use it to represent the uh, number of heads, that is 0, 1, and 2 here, since we are tossing two coins. So this is basically a random variable. Random variables can be of two types: discrete and continuous. Discrete means they are not in decimals and they are whole numbers. Continuous means they are in an interval. That is, for example, 50 to 60. So in descriptive statistics, the formula of mean is summation xi into frequency of the random variable divided by the total frequency. We won't be needing this, but just an information. So what is a discrete random variable? Discrete random variables are set of possible values that is either finite or countable finite. They do not lie in an interval and they are whole numbers. So what is a probability mass function? Probability mass function is basically a function of random variable x, such that when you substitute the value of x in that function, you'll get the probability of the random variable x in that experiment. For example, here in tossing a coin, probability of getting 0 is 1 by 4. That is probability of getting 0 heads. While we consider x as the number of heads, probability of getting 0 heads is 1 by 4. And similarly, probability of getting 1 heads is 1 by 4 plus 1 by 4, which will give us 2 by 4, which is 1 by 2. And similarly, probability of getting 2 heads is 1 by 4. There are some properties that PMF should satisfy. The first property is that f of x should always be greater than or equal to 0 for all values of x. Since probability is always greater than or equal to 0, and it should be less than or equal to 1 also. Since probability is always less than, lies in the interval 0 to 1, and the summation of f of x for all x should give us 1. This is a small question. We'll check if these can act as PMF. For first question, we'll substitute x is equal to 1. F of 1 is 1 minus 2 by 2, which is minus 1 by 2, which is less than 0. So f of x cannot act as an PMF. For the second question, we'll substitute 0, 1, 2, 3, 4, and see. 0 square by 25 will give us 0. Yes. 1 square by 25 will give us 1. Uh, 2 square by 25 will give us 4 by 25, which is 1 by 25. So sorry, which is less than 0. 3 square by 25 will give us 9 by 25, and 4 square by 25 will give us 16 by 25. These are all less than, these are all less than 1. So they are valid, but we have to check the summation to see if it equals to 1. So 0 plus 1 plus 4 plus 9 plus 16 by 25 will give us 30 by 25, which is not equal to 1. So this is not a valid PMF. In the third question, when we add 0.33 plus 0.33 plus 0.33, it will give us 0.99, which is not equal to 1. So this is not a valid PMF. One thing that many people forget is that they forget to check if the whole summation is equal to 1. So don't forget to check that. Cumulative distribution function. It is basically while we take a random variable x, we are checking the probability of all the in all the experiments that can happen for values less than the given variable x. So f of x is equal to p of x less than or equal to x, while x lies in the interval minus infinity to infinity. Here, for it, in this given table, p of x less than or equal to x will be, for x is equal to 0, p of x less than or equal to 0 will be 1 by 4. For x is equal to 1, p of x less than or equal to 1 will be p of for p of x less than or equal to 0, it will be p of x is equal to 0. For p of x less than or equal to 1, as we can see here, a random variables has 0, 1, and 2. Takes the values 0, 1, and 2. So p of x is equal to 0 plus p of x is equal to 1. Similarly, for p of x less than or equal to 2, we have to write it as p of x is equal to 0 plus p of x is equal to 1 plus probability of x is equal to 2. Basically, we have to take all the random variables which are less than the given random variable xi. Note, for in case of discrete random variables, p of x less than or equal to x is not equal to p of x less than x. For example, let us consider x is equal to 1. For p of x less than or equal to 1, we write it as probability of x less probability of x equals 0 plus probability of x equals 1. Whereas for p of x less than 1, we don't include 1. So we write it as probability of x is equal to 0. In case of continuous random variable, these two will be same. Expectation of a distinct random variable. So in this, so in normal statistics, we know that mean is equal to summation of xi into frequency by total frequency. So this can be written as probability of the random variable happening. So this can be written as summation of xi into p of xi, which will give us the formula for expectation of x. In discrete statistics, p of xi can be written as summation of xi into ni by summation of ni. This can be taken as the probability of xi, of the random variable xi. Note, p of x less than or equal to a can be written as 1 minus p of x greater than a, since the summation of the whole PMF should be equal to 1. Similarly, for p of x greater than or equal to a can be written as 1 minus probability of x less than a. Properties. So properties of expectations are expectation of ax plus or minus b can be written as a into expectation of x plus b. Here a is called as change of scale and b is called as change of origin. And expectation of any constant will give us constant. Why? So as we know, expectation will be equal to summation of xi into probability of that random variable. So probability of so suppose we consider the random variable to be b. So probability of B will be same for all the cases since it is a constant. So probability of B into 1. The whole summation will give us 1. So it will be B. Variance of a discrete random variable. So mean basically tells us how the values are centered, on which point the values are centered around, and variance tells us how much the values are scattered from that center. So variance can be written as expectation of uh, variance can be written as expectation of x minus x bar the whole square, which can be written as x. As we know, x bar is equal to expectation of x. So expectation of x minus expectation of x the whole square. This can be expanded to expectation of x square minus expectation plus expectation of x the whole square minus 2 into expectation of x into x. So this can be written as expectation of x square plus expectation of x the whole square minus uh, expectation of 2 into expectation of x into random variable x. How? Since we know that expectation of a x plus or minus b can be written as expectation a into expectation of x plus or minus b. So the expectation of x will always be a constant, and expectation of constant is equal to the constant itself. So this can be written as expectation of x square plus expectation of x the whole square. This can be written as minus of expectation uh, expectation of x into 2 into expectation of x into expectation of x. Since the whole term can be considered as a constant, it can be taken out. It will be considered as a here. So this will be expectation of x the whole square plus expectation of x square plus expectation of x the whole square minus 2 into expectation of x the whole square, which will give us expectation of x square minus expectation of x the whole square. This is the formula for variance. So some properties of variance are, and standard deviation is equal to square, variance is basically equal to standard deviation square. So properties of variance are variance of a x plus or minus b can be written as a square into variance of x. So people usually write plus or minus b here. Please don't do that. It is just variance of it is just a square into variance of x. This b will get cancelled. How? So this can be written as expectation of ax plus or minus b the whole square minus expectation of ax plus or minus b square. While we simplify it, we'll get expectation of a square into x square plus b square plus or minus 2axb minus expectation of ax minus expect. This can be taken out as a into expectation of x plus or minus b the whole square. So this will give us a square into expectation of x square plus b square, since expectation of a constant is constant, plus or minus 2a b into expectation of x minus a square into expectation of x the whole square plus b square plus or minus 2ab into expectation of x. These two will get cancelled, so it will be a square into expectation of x square minus expectation of x the whole square, which will give us a square into variance of x. And the second property is that variance of a constant is always equal to 0 by, so variance can be written as expectation of b square minus expectation of b the whole square, which will be b square minus b the whole square, which will give us 0. So we'll see some problems related to discrete random variables now. Is it clear for everyone so far? Okay. Okay, so basically, uh, so for this is the given probability distribution for us. We have to find the CDF of continuous. Okay, we have to find the CDF of x, and then we have to find the smallest value of x for which the CDF is greater than or equal to 0.5. So this is the probability distribution function. We can write it as x is equal to xi, p of x, probability of x is equal to xi, and probability of x less than or equal to xi. 0, 1, 2, 1 by 4, 1 by 2, and 1 by 4. This is given in the question. So CDF of 0 is probability of x less than or equal to 0 is probability of x is equal to 0. So it will be 1 by 4. Here probability of x less than or equal to 1 will be probability of x is equal to 1 plus probability of x is equal to 0, which will be 1 by 4 plus 1 by 2, which will be 3 by 4. Or you can just basically add these two and then write here. Similarly, here probability of x less than or equal to 2 will be probability of x is equal to 2 plus probability of x is equal to 1 plus probability of x is equal to 0, which will give us 1 by 4 plus 1 by 4 plus 1 by 2, which should give us 1. So CDF of the last random variable should always be equal to 1. You can use this to check if your answers are correct. So the first question is that they have asked us to draw the CDF table, which we have drawn, and then we have to find the value of it such least value of it such that the probability of x less than or equal to x is greater than 0.5. Here this is 0.25, which is less than 0.5. This is 0.75, which is greater than 0.5. So the answer for xi, for which probability of x less than or equal to x is greater than 0.5 is 1. We have to obtain the probability mass function from the given CDF. So CDF is basically trick to use CDF is that for probability of xi is equal to 0, you can directly write the value. For probability of I'm so sorry, 1 minute. Okay. So So for this, we have given as the CDF and random variables. So x is equal to xi and probability of x less than or equal to xi. Both of these are given for us in this second question. 0, 1, 2, 3. 0.1, 0.4, 0.9, and 1. Like I said, the last probability, the CDF of the last random variable, it should always be 1. Probability of x is equal to x. So for 0, you can, for the first random variable, you can write it as it is. Probability of x is equal to 1. We have to write it as probability of x less than or equal to 1 minus probability of x is equal to 0. Why? So probability of x is less than or equal to 1 will be probability of x is equal to 0 plus probability of x is equal to 1. So if we take it to this side, probability of x is equal to 1 will give us probability of x less than or equal to 1 minus probability of x is equal to 0, which is 0.3. Similarly, for probability of x less than or equal to 2, we have to write it as probability of x is equal to 0 plus probability of x is equal to 1 plus probability of x is equal to 2. Take these two to the other side, we'll get probability of x is equal to 2 as probability of x less than or equal to 2 minus probability of x is equal to 0 plus probability of x is equal to 1, which will give us, we can directly subtract these two also, because 0.4 is probability of x is equal to 0 plus probability of x is equal to 1. So 0.5, and then subtracting this from this, similarly we'll get 0.1 as the answer. The third question is, the number of hardware failures of a computer system is given. The random variable x is the number of failures and probability is given here. You have to find the mean. So mean is equal to expectation of x, which will give us summation of xi into probability of xi, which is given here. The answer is 1.82. And similarly for variance, we have to do expectation of x square minus expectation of xt whole square, which will give us the answer of 1.91. This is similar to the previous question. We are given the probability mass function, and then from that we have to find the expectation of x and then variance of x. So in this question, we are given the probability mass function. First, we have to find the value of k. So as a property of probability mass function, we know that its summation should always be equal to 1. So is equal to xi, probability of x is equal to xi minus 2 x1 1. So the summation of PMS should always be equal to 1. So 0.1 plus k plus 0.2 plus 2k plus 0.3 plus 3k should be equal to 1. 6k is equal to 0.6. 6k is equal to 6k plus 0.6 is equal to 1. 6k is equal to 1 minus 0.6. K is equal to 0.4 by 6, which will give us 1 by 15 as given here. So probability of, the next question is probability of x less than or equal to 2, which will be probability of x is equal to minus 1 plus probability, don't include minus 2 as it is not given equal to, just less than. So probability of x is equal to -1, probability of x is equal to 0, plus probability of x is equal to 1, plus probability of x is equal to 2. Oh, sorry. It is given as probability of x is less than 2, so we have to include x is equal to -2. Like that, like that. So adding up these values from the value we found out, the answer will be 0.5. Similarly, probability of -2 less than x less than 2 will be, we shouldn't include -2 and 2 as they are not included in this. So probability of x is equal to -1 plus probability of x is equal to 0 plus probability of x is equal to 1 plus, that's all. Which will give us the value as 0.4. CDF of the function. So CDF of the function is basically you have to add the previous values. For example, probability of x less than or equal to -2 will be probability of x is equal to -2. Similarly, for probability of x less than or equal to -1 will be probability of x is equal to -2 plus probability of x is equal to -1 and so on. And they have asked us for the expectation of x, which will be expectation of x is equal to summation random variable x into probability of the random variable x, which is 1.067 as given. And similarly, for variance of x, we need to find expectation of x the whole square, which is 3.6, and then subtract both of them. Okay, so in this question, they have asked us, in this third question, they have asked us to find the value of c. They have given the distribution table as 0, 1, 2, 3, 4, 5, 6, 7. So first we have to solve for k. As we know, the summation would be equal to 1. And here we'll get two values of k, since k is in quadratic form, but we should only take the positive values, since probability cannot be less than or equal less than 0. So k will be 1/10. Probability of they have asked for probability of x less than c such that it is greater than 1/2. X less than or equal to c such that it is greater than 1/2. So for that, we have to do the CDF table here. It is already did here. So in this, when we see probability of x less than or equal to 0 is 0. For 1, it is 0.1. For 2, it is 0.3. For 3, it is 0.5. And then for 4, it is 0.8. At 4 only, we are getting a value greater than 0.5. So C is equal to 4. This question. Okay. So fifth question. So fifth question, basically they have asked this conditional probability. So probability of 1.5 less than x less than 4.5 given x is greater than 2. As we all know, conditional probability for probability of a given b is probability of a intersection b divided by probability of b. So here probability of 1.5 less than x less than 4.5 intersection x greater than 2 divided by probability of x greater than 2. For that, we can draw a number line and see. Let this be 0, 1, 2, 3, 4, 5, and 6. So 1.5 will lie here. For the first question, it should lie between the value 1.5 and 4.5. So 1.5 and 4.5 are not included between this range. And similarly, it should be greater than 2 in this condition. So h should be greater than 2. So the random variables included here are this part, which is 3 and 4. We can't consider the decimal point since we are doing discrete random variables and they are whole numbers. So it will be probability of x is equal to 3 plus probability of x is equal to 4 divided by probability of x greater than or greater than 2, which can be written as probability of x is equal to 3 plus probability of x is equal to 4 divided by 1 minus probability of x less than or equal to 2, which will give us 5 by 7. Is this question okay for everyone? Okay. So we have another question. We are given a random variable x takes the value of 1, 2, 3, and 4. And then they have given us the probabilities values here. 2 into probability of x and so on. So we'll solve this question. We'll consider probability of x is equal to 1 as k. So the random variable x takes the values 1, 2, 3, and 4. So we have given 2 into probability of x is equal to 1 is equal to 3 into probability of x is equal to 2 plus 3 into probability of x is equal to 2, which is equal to probability of x is equal to 3, and which is equal to 5 into probability of x is equal to 4. So as we can see, this has no coefficients. So we'll take this as k. So probability of x is equal to 3, let us assume it as k. So comparing these two, 2 into probability of x is equal to 1 is equal to probability of x is equal to 3. So probability of x is equal to 1 will be k by 2, which is equal to k. So k by 2. Similarly, for here, 3 into probability of x is equal to 2 will be probability of x is equal to 3. So which is equal to k. So probability of x is equal to 2 will be k by 3. Similarly, probability will compare these two, and then probability of x is equal to 5 into probability of x is equal to 4 will be probability of x is equal to 3, which should be equal to k. Probability of x is equal to 4 will be k by 5. As we know, we'll create a table, PMF table for this. Xi, probability of x is equal to xi. K by 2, k by 3, k and k by 5. As we know, the summation of the probabilities in a PMF table must be equal to 1. So k by 2 plus k by 3 plus k by 5 should be equal to 1. So basically 15k plus 10k plus 30k plus 6k by 30 should be equal to 1. So k should be equal to 30 by 61. Using this, we can substitute the values in this table and then we can find the TMF, and from this we have to find the CDF. Is this question okay for everyone? Okay. So similarly, in this probability, we have to find the expectation of x, expectation of x square, variance of x, expectation of 2x plus 1, and variance of 2x plus 1. I'll do this and this. I'll tell you guys how to do it. So expectation of x will be summation of xi into probability of xi, which is 0.5 here. And then variance of x will be expectation of x square minus expectation of xt whole square, which is 1.25. Expectation of 2x plus 1. This can be written as in general terms, expectation of AX plus or minus B will be equal to A into expectation of X plus or minus B. So 2 into expectation of X plus 1 should be equal to 2 into 0.5 plus 1 should be equal to 2. And similarly, variance of 2x plus 1. So variance of AX plus B will be A square into variance of X. So here it will be 2 square into variance of X, which will be 4 into 1.25, which will be 5. So we are given a question here. Expectation of X is equal to 1 and expectation of X into X minus 1 is equal to 4. Variance of X by 2. So using this is also using the properties of expectations and variance. So expectation of given expectation of X is equal to 1 and expectation of X into X minus 1 is equal to 4. So this can be written as expectation of X square minus minus X is equal to 4. 1 minute. So this can be written as expectation of X square minus expectation of X, which will be equal to 4. So expectation of X square will be 4 plus 1, which will be 5. So they are asking us variance of X by 2. So variance of X by 2 can be written as a variance of AX plus or minus B can be written as A square into variance of X. Here A is equal to 1 by 2. So 1 by 2 the whole square into variance of X. Variance of X is equal to expectation of X square minus expectation of X the whole square. We have both the values of expectation of X square and expectation of X. So this can be 5 minus 1 the whole square, which should be equal to 4. So variance of X by 2 is equal to 1 by 4 into 4, which will be 1. This question is also very similar to this. Find the mean, variance, and then use the properties of expectations to find the expectation of 3x minus 4 and variance of 3x minus 4 using the expectation and variance we found now. We are finding before. Okay. So this is a different question basically. They have asked us, a coin is tossed until a head appears. What is the expected value of number of tosses? So coin is tossed. We are considering the number of heads, a number of tosses as random variable x. So probability of x is equal to xi is, for one toss we can get 1 by 2. That is okay. Let's go. So let x be number of tosses. So we are tossing until we get a head. So probability of head is equal to probability of tail is equal to 1 by 2 in an unbiased coin. So probability x is equal to xi, probability of x is equal to xi. So suppose what if we get head in first toss itself, then the probability will be 1 by 2. So what if we get head in the second toss, which means we didn't get head in the first toss, which means we got tail into probability of getting head, which will be 1 by 2 into 1 by 2, which will be 1 by 2 the whole square. Similarly, what if we are getting head in the third toss? So to get head in the third toss, the first two tosses must have given us tail. So probability of tail is 1 by 2 into 1 by 2. Probability of head is 1 by 2. So is equal to 1 by 2 the whole cube and so on. So we have to find the expectation of a tail appearing. So expectation of x is equal to summation of random variable x into probability of random variable x. Okay, so basically, sorry, they have asked us the expected value of number of tosses for head appearing. So sorry. So 1 into 1 by 2 plus 2 into 1 by 2 the whole square plus 3 into 1 by 2 the whole cube and so on. This is a geometric progression. So this is, this is a geometric progression and an AP progression together. So this can be written as 1 by 2 into 1 plus 2 into 1 by 2 plus 3 into 1 by 2 the whole square and so on. This is of the form 1 plus 2x plus 3x square and so on, where x is equal to 1 by 2. So this can be written as 1 by 2 into 1 by 1 minus 1 by 2 the whole square. So expectation of x will be 2. Is this sum okay for everyone? Okay. Okay, so this is very similar to the sum we saw before. They have given us the PMF here, and then we have to substitute R values here. R values are also given here, and then we have to sum it up to find the value of K, and then we have to find mean, variance, CDF, and then like I said, this question. For this question, probability of 1 by 2 less than x less than 5 by 2 given x greater than 1. This can be written as 0.5 less than x less than 2.5 given x greater than 1. So for conditional probability of A intersection B, given probability of B. So here it should be drawing a number line 0.5, 2.5 and 1. So it will start from here to here, and then for probability of B it will go from here. So these two values, which will be probability of x is equal to 2, which is given here. And the CDF table is also given. Till this, is this okay for everyone? Is there any doubt? Okay. Shall I move on to moments? Is it okay?
Danya has her hand raised.
Yeah, that's good. Danya?
No, by mistake.
Okay. Okay. So moments. So basically, why do we need moments? So basically, moments are expectation of x power r, where x is the random variable. Okay, so basically, why do we need moments, like I started with before? Now we are using expectation of x and expectation of x square, which is okay. But what if we need to find expectation of x cube and expectation of x power 4 and so on? It will be very tedious for us. So we are using moments. We are, so we are going to use moments for that. So moments, there are different types of moments. First moment is moment about origin, which will be which is also called as raw moments. So here first moment about origin will give us the random variable x. Second moment about origin will give us expectation of x the whole square. So basically there is a general form of moments, which is expectation of x minus a the whole square, where a expectation of x minus a to the power r, where r is an integer and a is also an integer. This is the general form of moments. In this, for origin, we'll substitute a is equal to 0, and then for mean, we'll substitute a is equal to mu. So when we substitute a is equal to mu, expectation of x minus mu to the power 1 will be 0, as we know, because expectation of x minus expectation of mu, which is both mu, which will cancel out and give us 0, as it is. The second moment about mean will give us the variance of x, which is expectation of x minus mu the whole square, which is same as expectation of x minus expectation of x the whole square, which will give us variance of x. The third moment about mean is used to find skewness uh, of the given graph, and then the fourth moment about mean is used to find the kurtosis. Kurtosis means how flat the curve is, and skewness means how much, like how to say, how much the curve is tilt, is symmetric basically. How much in which side it is more concentrated, like this, like this. Okay, so we don't need this. Mostly it won't be asked. So but it is better if you know the second moment alone. What is the relationship between raw moment and settled moment? For second moment about mean alone, it is better to know, because we'll be using it for variance, which is mu2 dash minus mu1 dash the whole square. Basically, expectation of where mu2 dash is the second moment about origin and mu1 dash is the second moment about mean. This is basically expectation of x square minus expectation of x the whole square. We won't be needing the third moment and the fourth moment. So this is the formula to find the rth moment about for both about origin and then for about me. But we won't be using this. We'll be using moment generating functions, since it will be too much calculation over here. Like I said, some key moments are first moment about the first moment about origin will give us the expectation of x, that is the center of probability. The second moment about mean will give us the variance. Third moment will give us the asymmetry or skewness, and the fourth moment will give us the kurtosis or flatness of the curve. Okay, so moment generating functions, like I said, we'll be using moments to study the data that is given to us. So it will be very tedious to perform expectation of for expectation of x power 4, x power 5 and all using this formula. So for this, we can use moment generating functions. So moment generating functions is basically, this is the formula for moment generating functions. That is, a moment generating function is equal to mx of t is equal to sigma expectation of I is summation of I is equal to 1 to n e power t h I into t of h I, where t is an independent variable. It does not depend on x at all. So how do we get this formula? So basically, uh, this is basically of the form expectation of e power t of xi. So as we all know, the expansion of e power x is equal to 1 plus x by 1 factorial plus x square by 2 factorial and so on. Expectation of x, we'll write it as t of xi. So it will be 1 plus tx by 1 plus t square x square by 2 factorial and so on, which will be e power t of xi. Applying expectation over here, we'll get expectation of 1 plus t of x tx divided by 1 factorial t square x square by 2 factorial and so on, which will be according to properties of expectations. We know that expectation of ax plus or minus b is equal to a into expectation of x plus or minus b, which will be expectation of 1 plus expectation of t of x by 1 factorial plus expectation of t square x square by 2 factorial and so on. So which can be written as 1 plus t by 1 factorial into expectation of x plus t square by 2 factorial into expectation of x square and so on. This is how we get this form. So as this can be written as 1 plus t by 1 factorial into mu 1 dash plus t square by 2 factorial into mu 2 dash and so on. So if we have, this is mx of t. So if we have an equation of this form, from this we can find the rth moment by finding the coefficient of t power r by r factorial. Coefficient of t power r by r factorial will give us the rth moment about origin. The second method is we'll take mx of t and then we'll take its derivative and then we'll substitute t is equal to 0. So basically when we get the derivative, uh, when we take the derivative, the other terms will get cancelled. For example, with respect to t, this will become 1 and this will become 0. This will become 2t and so on when we take the derivative. When we substitute t is equal to 0, this term and the other terms will get cancelled. So we'll have only mu 1 dash. So basically for r rth moment, which will be the rth derivative of the mgf with respect to t and then substitute t as 0. Note, this can only be used when t is not in the form of t inverse and so on. When it is in the form of t inverse or as such, when we differentiate it with respect to t, it will become t power minus 2, which will be in the denominator. And when we substitute t is equal to 0, it will give us infinity, which is not the answer. In case of when we have t power minus 2 or so on, then we have to use the first method, that is coefficient method. Till now, is this okay? Any doubts? Okay, great. So we'll move on to this and then we have just 2 more distributions and then we'll be done with this chapter. Okay, so if x represents the outcome when a pair of fair dice flows, find the mgf of random variable x. So we are given the probability distribution here. Mgf of x is equal to mx of t is equal to e power txi into probability of xi, where xi is the random variable x and t is a variable independent of x. So when we substitute xi here, we'll get this formula, which will be mx of t is equal to 1 by 6 into e power t plus e power 2t and so on till e power 6t. For e power x, we have, if we get a question like this, hence find e power x and variance of x, we have to find only using mgf unless and until we are not able to find it in cases like t power minus 2 and so on. Otherwise we have to find it only using mgf. So we have found the mgf here. For the first moment about e power x, expectation of x is basically first moment about origin. First moment about origin, we can differentiate it once and then put t is equal to 0. So when we differentiate it once and put t is equal to 0, we'll get the answer as 7 by 2. And for variance of x, which is the second moment about mean, the formula is mu 2 dash minus mu 1 dash the whole square, where mu 2 dash is the second moment about origin and mu 1 dash is the second moment about mean. I mean second moment, the first moment about origin. So to find mu 2 dash, we have to double differentiate mgf and then substitute t is equal to 0. So this will give us this value. Substituting in this formula, we'll get the answer. Is this question okay? Okay. So MGF, we are given probability of x is equal to x as 1 by 2 power x, where x is 1, 2, 3, and so on. So the PDF table for this will be 1 by 2, 1 by 2 square, 1 by 2 for 3, 1 by 2 cube, and so on. So this question is this can be done in two methods. So as we know, mx of t will be equal to sigma I is equal to 1 to n e power xi into t into probability of xi. This is a never ending series, so we'll substitute xi as 1, 2, and for some variable, so it will be e power t into 1 by 2 plus e power 2 into 1 by 4, and so on. When we take e power t by 2 as common, we'll get this value. Here, this can be written as e power 1 plus e power t by 2 plus e power t by 2 the whole square. Since 2 square is 4, and then this 2 can be taken out, this can be of the form 1 plus x square, and so on. This can be written as 1 by 1 minus x. So where x is equal to e power t by 2. So mx of t will be e power t by 2 minus e power t. So from this we have to find the mean and variance. Similar to what I said, we have to differentiate it once to find mu one dash, which is the expectation of x, and then we have to differentiate is to find mu two dash, which can be used to find the variance, which is equal to mu two dash minus mu one dash the whole square. Okay, so we have to find the MGF for a random variable x whose moments are 1 minute. Yeah, sorry. So find the MGF of the random variable whose moments are as follows. So moments are given here. We have to substitute for r is equal to 1, 2, 3, and 4 to form a pattern. So basically for r is equal to 1, we'll get 4. R is equal to 2, when we substitute, we'll get it as 24, 3, 192, and 4 or as 1920. How can this be written? So basically, mx of t is can be written as 1 plus t by 1 factorial into mu 1 dash plus t square by 2 factorial into mu 2 dash, as we saw earlier. So substitute mu 1 dash, mu 2 dash, mu 3 dash here. So this can be written as 1 by t into 1 factorial into 4 plus t square by 2 factorial into 24 plus t cube by 3 factorial into 192, and so on. How can this be further written? So basically we'll cancel this, so which will give us 12. 12 can be written as 2 in 3 into 4. So this can be written as 2 into 2t plus 3 into 4t square. When we cancel this and then when we take it out, we'll get 32, which can be written as 4 into 8 plus 4 into 8t cube. Why are we doing this? Basically, we have 4 formulas. So 4 binomial expansions, 1 minus x power minus 1, 1 by 1 plus x power minus 1, 1 by 1 minus x power minus 2, 1 by 1 plus x power minus 2. It will be better for us if we are able to represent MGF in any one of the following ways. So when we write it in this form, we'll get it as 1 plus 2 into 2t plus 3 into 2t the whole square. This can be written as 2t the whole square and 2t the whole cube, and so on. So this is of the form 1 minus x power minus 2, where x is equal to 2t. MGF So this will give us the MGF as 1 minus 2t power minus whole power minus 2, which is the MGF. Okay. So here in this question, they are giving us the MGF that we found in the previous question, and then they are asking us to find the moments. There are two methods for this. One method we can expand it like this, and then when we expand it, we'll okay. So when we expand 1 minus 2t power minus 2 to be 1 plus 2 into 2t plus 3 into 2t square and so on. So be 1 plus 4t plus 3 into 4 into t square plus so on. But our normal MGF is of the form 1 plus t power 1 by 1 complement into mu 1 dash plus t square by 2 complement into mu 2 dash and so on. To bring this factorial terms inside, we have to multiply and divide them by the respective factorial terms. So 1 plus 4 into 1 factorial by 1 factorial into t plus 12 into 2 factorial by 2 factorial into t square and so on. So be 1 plus uh, 4 into t by 1 factorial plus 12 into 2 is 24, 24 into t square by 2 factorial and so on. This is of the form 1 plus mu 1 dash into t power 1 by 1 factorial plus mu 2 dash into t square by 2 factorial and so on. Comparing these two expressions, we'll get mu 1 dash as 4, mu 2 dash as 24 and so on it goes. And the second method is the derivative method. We can use the derivative method to find, we can, as we know, the arc moment about mean is equal to arc derivative of the MGF with respect to t, and then substitute t is equal to 0. For mu 1 dash, we have to differentiate it once and then substitute t is equal to 0. And then similarly for mu 2 dash, we have to differentiate it twice and substitute t is equal to 0. In case this MGF is of the form 2t power minus 1 or something like that, we can't use the second method, because the second method will give us 2t power minus 1 into 2t power minus 2 after differentiating, and when we substitute 0 in it, it will become 1 by 0, which will be infinite. Okay, so this is the next question. They are given as the f of x and they have asked to find us the MGF. So as we know, mx of t is equal to e power txi into probability of x, so summation. So at x is equal to 1 and 2 we are given. So mx of t is this. Mu 1 dash will be differentiated with respect to t once and then put t is equal to 0, which is this. And mu 2 dash will be differentiated with respect to t twice and then put t is equal to 0, which can be used to find the variance, which is mu 2 dash minus mu 1 dash t square. Okay, so a perfect coin is tossed 3 times. If x denotes the number of heads that appears, find the MGF of x. So the sample space will be triple H, HTH, THH, TTH, HT, HTT, THD, and TTT. X can take the values 0, 1, 2, 3. So the PDF is written here. From this, we know that expectation MH of T will be so MH of T will be e power txi summation e power txi into probability of xi. So substitute the values in this and then we'll get mx of t. So differentiated with respect to t, we'll get mu 1 dash, mu 2 dash, and from this we can find the variance. Okay. So far is this good? Is it okay for everyone? We'll move to distributions. Okay. So distributions of discrete random variable. So basically, there are two distributions for us: binomial distribution and Poisson distribution. The Poisson distribution is basically the cases where binomial distribution does not work, or limitation case of binomial distribution. So what is Bernoulli's trial? Basically, a trial which has two possible outcomes. One is a success or a failure. For example, if we take our experiment as a number as a probability of getting head, then probability of getting head will be considered as success, and probability of getting tail will be considered as a failure. And similarly, while we roll a die, if we consider getting even numbers as success, then getting odd numbers will be considered as failures. So what is a binomial experiment? So basically, when we do this binomial trials for n times, it is called as binomial experiment. Suppose if we repeat the same tossing of coins for say 100 times or so, it is called as a binomial experiment. Okay. So a small note is that all trials are independent of each other. That is the outcome of the first trial. That is the outcome of tossing the coin for the first time does not affect the outcome of tossing the coin for the second time. Okay. So these are the properties that a binomial experiment must possess. First one, it must have fixed number of trials. The number of times this tossing of coin happens must be finite. It must be fixed. It cannot be infinite. All trials must have identical probability of success. For example, if for the first time I toss an unbiased coin, and second time I toss a biased coin, and then I get the probability of getting head for the first time as 1 by 2 and second time as 1 by 4, then it will not be considered as a binomial trial, because the probabilities of success is not identical, and the trials must be independent of each other, like we saw. What is binomial distribution? For any independent binomial trials, a random variable is set to follow binomial distribution if it assumes only non-negative values and its probability mass function is given by this. So basically, uh, for n independent binomial trials and n is finite, probability of success is p and probability of q is 1 minus p. These are n and p are the main parameters of binomial distribution. If a random variable x follows these properties, then it is said to be in binomial distribution, and its PMF will be given as NCx into p power x into q power n minus x, where x is the random variable 0, 1, 2 up to n, where n is the total number of trials, and p is the probability of success, q is 1 minus p, which is the probability of failure. It is 0 in all other cases. Like I said, n and p are called the parameters of the distribution, and n is also known as the degree of binomial distribution. Like for example, if n is equal to 60, then the degree of the binomial, for example, if we are tossing a coin for 60 times, then the degree of this experiment will be 60. And okay, so some properties, these are the same properties as probabilities, general probability. Probability of xi must always be greater than or equal to 0, and it should be less than 1. So summation of probability must be equal to 1, like I said. There is also a reason for this, like you can justify if asked. Like for binomial distribution, um, this is the PMF of the binomial distribution. This can be written as of the form P plus Q power n. This is the general expansion of P plus Q power n, and Q is equal to 1 minus P. So P plus 1 minus P power n. This will get cancelled, which give us 1 power n, which is equal to 1. You don't need you MGF of the distribution. You don't need to know the derivation, but you can just know the formula alone. The formula is mx of t into e power t p plus q power n. Just remember it as spect p in t plus q to the power n. This is the mx of t, and then from this, when we differentiated once with respect to t, we'll get expectation of x as np. That is the mean. The mean of random variable x which follows binomial distribution is np, and the standard and the variance, that is standard deviation square, is npq. That is np into 1 minus p. Okay, so we'll see the sums here. Usually toying sums with just 2 or 3 times tossing can be solved generally by, like in these cases, it can be solved using normal probability or using binomial distribution. But if they specify you to solve using binomial distribution, then you have to use the specified method. Uh, Okay, so a fair coin is tossed 3 times. Find the probability of getting exactly 2 heads. So this method will be known for everyone. The first method, which is like writing the sample phase and finding the probability. We'll see the binomial distribution method. Basically, we'll write the sample space over here, and then we'll find all the number of favorable outcomes, which is 1, 2, and 3. 3 by total number of elements in sample space is 8, which will be 3 by 8. So binomial distribution here, n is equal to 3, and expectation of and probability of head is equal to 1 by 2. That is probability of success here, where it's random variable x denotes the number of heads. And then so we have to find exactly 2 heads. So x is equal to 2. So for generally p of x is equal to x, we'll get nc x into probability of x, p power x into q into n minus x. So q will be 1 minus 1 by 2, which is 1 by 2. So this can be written as n is equal to 3, 3c2 into 1 by 2 to the power 2 into 1 by 2 to the power 3 minus 2. So 3c2 is 3 into 1 by 2 to the power 3, which will be 3 by 8. So in this case, a coin is tossed 4 times. What is the probability of getting at least 2 heads? So basically, a coin is tossed 4 times. N is equal to 2. P is equal to 1 by 2. While we assume x as the number of heads. So we have to find probability of getting at least 2 heads. P of x greater than or equal to 2 will be equal to P of x is equal to 2 plus P of x is equal to 3 plus P of x is equal to 4. As we know, probability of x is equal to x for a variable following binomial distribution is nc x into p power x into q power n minus x. Okay. Um, okay. So here it is given p of x is equal to 2 plus p of x is equal to 3 plus p of x is equal to 4. So n is equal to 4. So this can be written as 4c2 into 1 by 2 power 2 into 1 by 2 power 4 minus 2 plus 4c3 into 1 by 2 power 3 into 1 by 2 power 4 minus 3 plus 4c4 into 1 by 2 power 4 is to 1 by 2 power 4 minus 4, which will give us the required answer, which will be 11 by 16. Okay. So the mean of a binomial distribution is 20 in this sum. So NP is equal to 20 for binomial distribution, and standard deviation is 4. That is sigma is equal to 4. Sigma square is equal to variance of x is equal to 16, which is equal to NPQ. So NP is equal to 20, NPQ is equal to 16. Divide both of them, we'll get 1 by q is equal to 5 by 4, q is equal to 4 by 5. From this, they have asked us to find the parameters. That is, they have asked us to find n and p. we have found Q here. So P will be Q is equal to 1 minus P. So P will be 1 minus Q. So be 1 minus 4 by 5, which will be 1 by 5. And then similarly, we have NP is equal to 20. That is N into 1 by 5 is equal to 20. So N is equal to 100. Okay. So comment on the following. The mean of a binomial distribution is 3 and variance is 4. So NP is equal to 3 and NPQ is equal to 4. We have to check if this is possible. So dividing these two, we'll get 1 by Q as 3 by 4. Q is equal to 4 by 3, which is greater than 1, which is not possible. So this distribution does not exist. Okay. So this is similar to the previous two sums. The mean and variance are given. From this, we have to find the parameters, that is n and p, and then we have to find p of x greater than or equal to 2, which will be 1 minus p of x less than 2. To be 1 minus probability of x is equal to 0 plus probability of x is equal to 1. From solving this, we get to know that p is equal to 1 by 4 and n is equal to 32. So this will be 32 C0. The general form will be 32 CX into 1 by 4 power x into 1 minus 1 by 4, which will give us 3 by 4. 3 by 4 to the power 32 minus x. So for it, probability of x is equal to 0 and x is equal to 1, we'll substitute x is equal to 0 and x is equal to 1 and simplify. So in a consignment of electric bulb, 10% are defective. So probability of defective is 0.10 and a random sample is taken for inspection. So find the probability that all are good bulbs. Almost there are 3 defective bulbs. Exactly there are 3 defective bulbs. Okay. So how do we find that it is binomial? So they are given as the probability and they are given as the number of samples. Usually when n and probabilities are given, then it is generally for binomial. So for Poisson, mean will be given. For binomial, we are given n and p. So we'll consider the random variable x to be defective bulbs. Number of defective bulbs. So n is equal to 20, p is equal to 0.10, and q is equal to 1 minus 0.90, which is 0.90. So PMF will be of this form: 20 Cx into 1 by 10 power x into 9 by 10 power 20 minus x. So first one, all are good means there are no defective bulbs. So P of x is equal to probability of x is equal to 0. Almost there are 3 defective bulbs. At most there are 3 defective bulbs means P of x less than or equal to 3, which will be probability of x is equal to 0 plus probability of x is equal to 1 plus probability of x is equal to 2 plus probability of x is equal to 3. Substituting in this, and then we'll get the answer as 0.8666. And they have asked exactly 3 defectables. That is probability of x is equal to 3. So binomial frequency distribution. So basically, till now we were finding the probability of the random variable x happening. Suppose we are given, say, we'll take the example of tossing the coin itself. Suppose we are given, we are going to perform it for 100 coins. So they will ask us, if it's performed for 100 times, then it will they might ask us based on the probability how many coins will be of heads and how many coins might have gotten tails based on what we got. That is basically binomial frequency distribution. Here if you can see, out of 800 families, so 800 families is the n frequency of is given as n into probability of x, where n is the number of times the experiment is done. For n trials is different than number of times the experiment is done. So this can be written as we know, probability of a binomial function is NCX into probability of x into q power n minus x. So there's a question given for us. 1 minute. Okay. So out of 800 families with 4 children each, how many families would be expected to have these conditions? So here 800 families will be in, that is the total amount we are for, like, how to say, total number of uh, like the sample space here. Basically they are the sample space here, and then 4 children is number of trials here. So number of times this experiment is repeated for each sample space. That is basically the difference between a small n and capital N. So how many times, when we get the keyword how many, then it usually follows binomial frequency distribution. So how to take this? N is equal to 4. Let us assume random variable x to be number of boys. N is equal to 4. Both girls and boys have equal probabilities, so probability of success is equal to 1 by 2. Probability of that is girls is equal to 1 by 2. So basically PMF will be NCX into P power x into Q power n minus x. So this can be written as 4CX into 1 by 2 power x into 1 by 2 power 4 minus x. So first they are asking 2 boys and 2 girls. That is probability of x is equal to 2. So probability of x is equal to 2 will be, substitute 2 in this EMF equation and then you will get a probability. With this probability, to get the how many families will have 2 boys and 2 girls, multiply capital N, that is in this case 800. 800 into 3 by 8 will be 300. That is 300 families will have 2 boys and 2 girls according to the data we have. Similarly, at least one boy. P of x greater than or equal to 1. So which can be written as 1 minus probability of x less than 1, and then solve. From this, we have to find how many families will have at least one boy. That is 800 into probability of x greater than or equal to 1, which will be 750. Similarly, they have asked us utmost two girls. That is, probability of utmost two girls is two girls, one girl, or no girls. So probability of at least two boys. That is, usually we have to write it in terms of x1. So this will be probability of at least two boys. Probability of x greater than or equal to, this probability of x is equal to 4 plus 3 plus 2. Substitute in this and then you will get the answer. Multiply it with 800 and then you get the answer as 550. To find the number of families with utmost totals. So probability of children of all genders. That is basically they have both boys and girls. How to do that? This will be 1 minus probability of them having only girls or them having only boys. Them having only girls is probability of x is equal to 0. Since there are no boys, or probability of x is equal to 4. Uh, Substitute in the given uh, PMF equation, and then we'll get a probability, multiply it with n, which is the total number of families, to get the number of families with all genders, that is both boys and girls. Okay, so 6 dice are thrown 729 times. So 6 dice. Here n, small n is 6 and capital N is 729. How many times do you expect 3 dice to show, either 5 or 6? 3 dice should show either 5 or 6. So basically at least 3 dice. So basically probability of it's greater than or equal to 3. What is probability of success and failure here? First we have to decide that. So probability of success is showing success is showing 5 or 6 for a die here. That is probability of 5 or 6. Since these two are independent, this can be written as probability of 5 plus probability of 6, which will be 1 by 6 plus 1 by 6, 1 by 3. The probability of failure is 1 minus b, which will be 1 minus 1 by 3, will be 2 by 3. So we have to construct PMF using this. N is equal to 6 and probability of success is equal to 1 by 3. So PMF will be 6X into 1 by 3 power X into 2 by 3 power 6 minus X. Probability of X greater than or equal to 3 can be written as, since we don't know how many times this will go on, this can be written as 1 minus probability of, that is, it may be difficult to calculate for 6, 5 and 4. So we can write it as probability of X is equal to 0 plus probability of X is equal to 1 plus probability of X is equal to 2. So if we substitute in this, and then we'll get the answer as 233 by 729. To find how many times, how many dice will at least have, uh, to find, sorry, how many times will have at least 3 dice, with probable, how many times there will be at least 3 dice which will show 5 or 6. We have to multiply the sample space, that is bigger n, with the probability we have we got, that is 233. Here it means that 233 times the dice will show either, at least 3 dice will show either 5 or 6 out of 6 dice thrown. Okay, so probability of a bomb hitting a target is 1 by 5. Probability of a bomb hitting a target is 1 by 5, and 2 bombs are enough to destroy a bridge basically. If 6 bombs are aimed at the bridge, find the probability that the bridge is destroyed. So 2 bombs are enough to destroy a bridge, that is at least 2 bombs are required for probability of success, that is to destroy a bridge. So we have n is equal to 6, and then probability of success is equal to 1 by 5. Failure is 1 minus 1 by 5, so will be equal to 4 by 5. And then we have to find probability of X greater than or equal to 2, where X is the number of bombs. So PMF will be 6X into 1 by 5 power X into 4 by 5 power 6 minus X. Substitute P of X greater than or equal to 2 can be written as 1 minus probability of X less than 2, which will be probability of X is equal to 0 plus probability of X is equal to 1. Probability of X less than 2. Substitute X is equal to 0 and 1 in this formula, and then you'll get the answer. So the second question is, the probability of a man hitting a target is 1 by 4. If the man fires it 7 times, what is the probability of him hitting target at least twice? So basically probability of success is 1 by 4, n is equal to 7. We have they are asking us probability of X greater than or equal to 2. This is similar to the previous problem. We have to form the PMF, which will be this. Substitute the required random variable, and we'll have to find the answer. Is binomial distribution okay for everyone? Hello? Okay. Okay, so pause. After this, we'll just look at some problems and then we'll take a break. So Poisson distribution. Poisson distribution is basically the limiting cases of binomial distribution. So the PMF for Poisson distribution will be e power minus lambda into lambda h by h factorial, where x is the random variable and lambda is the only parameter, which is the mean. Here mean can be written as NP. Poisson distribution. Suppose by it is used when the number of trials is infinitely large, that is it tends to infinity, but the probability of success is very small, that is it tends to 0. In that case, we'll use the Poisson distribution. So you don't have to know this. This is just the derivation. You have to know the final formula alone. E power minus lambda, lambda power x into divided by x factorial, and you have to know that lambda will be np, which will be finite. Reason, as n tends to infinity and p tends to 0, these two will balance each other and it will be finite. mgf of mgf of uh, mgf of Poisson distribution is this: mx of t is equal to e power lambda into e power t minus 1, where lambda is the mean or parameter of Poisson distribution and t is an independent variable. So for getting mu1 dash and mu2 dash, we have to differentiate it with respect to t and then substitute it with 0, which in both the cases gives us lambda. So basically, uh, mean and variance for Poisson distribution is the same, which is equal to the parameter lambda. So Poisson distribution is used when NP is less than 5. That is, when NP is greater than 5, the Poisson distribution will almost be similar to binomial distribution. Usually, n is greater than 20 and p is equal to 0.05. Probability of success. Probability of success. Okay. So, the first question: if X is a Poisson variate such that this is the condition given, then we have to find mean, variance, and probability of X greater or equal to. Mean and variance are same as lambda, and we have to find this alone. So, probability of x is equal to here is e power minus lambda into lambda power x by x factorial. The probability of x is equal to 2 will be e power minus lambda into lambda square by 2 factorial, which is given to be equal to 9 into e power minus lambda into lambda power 4 by 4 factorial plus 90 into power minus lambda into lambda power 6 by 6 factorial. We can simplify this by cancelling out e power minus lambda and lambda square. So it will be 2 factorial can also be cancelled. Should be 3 into 4. 6. Cancelling this. Similarly, 3, 30. Is at 30. So we'll get 1 is equal to so we'll get 1 is equal to 3 in 3 by 4 into lambda square plus 1 by 4 into lambda power 4. Should be lambda square, should be lambda power 4. So taking this to the other side, 4 is equal to 3 into lambda square plus lambda power 4. We'll assume lambda square to be x. So 3 3x plus x square minus 4 will be equal to, solving this we'll get lambda square is equal, sorry, solving this which is already done here, we'll get lambda x square x is equal to 1 or x is equal to -4, which is not possible since lambda's square number are always greater than 0. So lambda can be equal to plus or minus 1, but lambda must always be greater than or equal to 0. Why? So lambda is equal to NP. N is the number of trials which must always be greater than 0, and P is the probability of success which must always be greater than 0. So NP will always be greater than 0. So lambda is equal to 1. Uh, so substituting this in this formula, that is probability of x greater than or equal to 2 will be, so what is the PMF for this? So P of x is equal to x will be e power minus 1 into 1 power x by x factorial, which will be e power minus 1 by x factorial. The probability of x greater than or equal to 2 will be 1 minus probability of x less than or less than 2, be probability of x is equal to 0 plus probability of x is equal to 1. Substituting 0 and 1 in the PMF given, we'll get the answer as this. Okay. So this is the last sum, and then after this we'll take a short break. So the number of monthly breakdown of a computer is a random variable having a Poisson distribution with mean is equal to 1.8. Lambda is equal to 1.8. And the probability that this computer will function for a month without a breakdown, with only one breakdown, and with at least one breakdown. So here X will be number of breakdowns in a month. Okay. So P of x is equal to x will be e power minus lambda into lambda power x by x factorial. So lambda is equal to 1 power 8 will be P of x is equal to x will be e power minus 1.8 into 1.8 to the power x by x factorial. So without any breakdown means probability of x is equal to 0. With only one breakdown means probability of x is equal to 1. And with at least one breakdown means probability of x greater than or equal to 1, which will be 1 minus probability of x less than 1, which is 1 minus probability of x is equal to 0. Substitute the values in this PMF and then you'll get the answer. That's all. Is this okay so far? Any doubts in this chapter?